to this YouTube video, and in this video we're going to be looking at exact differential equations, but we're going to be looking at case 1 and case 2 of exact differential equations, right? So now for this one we have if you are given an equation, a differential equation, and then you check if it is an exact differential equation, that means you check if so if you check if the y is equal to the x, and you check and it is not equal to each other, then you are going to either have case 1, or you have case 2, or you have case 3, or you have case 4, or you have case 5, right? So in this video we're going to look at the 2 other cases that you could possibly have, right? So now the first case is if, let me just put it here, and we have case 2 here. Alright, so now for case 1, if the y minus the dx over n is equal to a function of x, then you're going to have your integrating factor as e to the integral of f of x dx. But for case 2, if your if your dn dx minus dm dy over m is equal to a function of y, then your integrating factor is going to be equal to e to the integral of f of y dy, right? So this is for case 1 and case 2, right? And this you only do this when dm dy is not equal to dn dx. That's the logic, that's the idea behind it, right? So now the idea is, so if you do that, you check if it's exact, the base form of the exact, and it does not work, you can check for case 1 and case 2. So if you check case 1 and then you get it to be a function of x, you are going to now find your integrating factor, right? So it is a 4-step approach. So the first step, you're going to check if it is exact. If it's not exact, you check for case 1 or you check for case 2. So if you check and it is a function of x, then you are going to find the integrating factor using this formula. And then if you check for case 2 and it's a function of y, you are going to use the integrating factor using this formula that we have here. So after getting the integrating factor, you are going to multiply the original equation by the integrating factor that you just got. And after you have gotten the new equation, after multiplying by the integrating factor, what you are going to do now is that you are going to now solve using the method for the base form, right? You're not going to solve using the method for the base form, which is basically you just integrate the values of m and then you integrate the value of n that has only y variable, right? So very, very simple. So I'm going to take one question under case 1 and one question under case 2. Right, so let's go ahead. So for case 1, the question I'm going to use is going to be 2x log x minus xy dy plus 2y dx is equal to 0. So I have this question, right? So this question is a question that does not follow the exact. I don't want it to be too lengthy. If not, we would have just checked. But you can pause the video to check if it's an exact differential equation, right? But it is not, right? So now we're going to have our m, and our m is going to be 2y, right? Because our m is with the dx. Don't make the mistake and go and take this as your dm. It's not dm. Our m is with dx. So we have m to be equal to 2y, and then we have our n. Okay, let me just find the m dy, which is just going to be equal to 2, right? And then we have the n, right? So we have our n here to be equal to 2x log x minus xy, and then we're going to have the n dx. So now for the n dx, right, 2x is multiplying log x, so that means we are going to be using product rule. So we're going to integrate 2x and we're going to get 2, then we're going to multiply with log x, then plus the derivative of log x, which is 1 over x, multiplied by 2x, which is going to give us 2, right? So we have 2x log 2 log x plus 2 for that part. Then we have negative xy. So now we're going to be differentiating xy. When we differentiate that, we're just going to get negative y. So we have that, and then we can just solve. Right? So we're solving using case 1 now, right? So now case 1 is dm over dy minus dn over dx over n, right? So dm over dy is what? Is 2, then minus dn over dx, which is going to be 2 log x plus 2 minus y, right? Then all over n, and our value for n is 2x log x minus x y. So we have that. Let me do it like this. All right, so we have that. So now for this expression here, so we're going to have 2. I'm going to open the brackets now. 2 minus 2 log x minus 2 plus y. Then we have over 2x log x minus xy, right? So here 2 is going to cancel this out. So we have minus 2 log x plus y over 2x log x minus x y. And what we can do here is that we're going to factorize negative 1 out for the one at the bottom, and the one at the top. For the one at the bottom, we're going to factorize x out, and the one at the bottom, we're going to factorize negative 1 out, so that we can cancel out the things that are common. So we're going to have negative 1 in bracket 2 log x. So we're going to have negative 2 log x, right? Negative 2 log x. No, we're going to have 2 log x because we already factorized negative 1 now. So we have 2 log x minus y, then over x 2 log x minus y. So this is going to cancel out this, and then we can see that it is equal to negative 1 over x, which is a function of x. When we say something is a function of x, it means that it has only x variables, right? And when we say something is a function of y, it means that it has only y variables. So this minus 1 over x now is equal to a function of x, and then we can now find our integrating factor, right? So the first step, is to still find your dm dy, find your dn dx, and then you now check the condition. You check whether dm dy minus dn dx is equal to a function of x, right? So if it's equal to a function of x, you find your integrating factor using this formula that we are using now, e to the power of f of x, the integral of f of x, which is negative 1 over x, we have dx, right? So this is going to be equal to the exponent of negative 1 over x dx, which is equal to the exponent of negative ln x, which is equal to the exponent of ln x to the power of negative 1. This will cancel this. So we have x to the power of negative 1, which equals to 1 over x. So the integrating factor now is 1 over x. Remember I said that we're going to use it to multiply the original equation, right? So we're going to have multiply everything in the original equation. So we're going to have 1 over x multiplied by, right, 2x log x minus xy dy plus 1 over x multiplied by 2y dx is equal to 0, right? So now if you multiply 1 over x into the bracket, we're going to have 2 log x, right? Then put the bracket back, so we have minus y dy, right? We have that, and then we're going to have plus 2y over x dx is equal to 0. So we have this now, and then we're just going to use the base form, right? After you arrive at this form, after you have used the integrating factor to multiply the entire equation, what you're going to do next is that you are now going to go back to the base form of exact differential equation, where you just integrate the values of n with respect to s plus the integral of n dy is equal to c, right? But you are taking only the values of y that has y alone. The moment it has x, you are not going to be integrating it. So let me just clean all of this part, right? So yeah, so now we're going to be integrating 2 log x minus y. Okay, no, sorry about that. So this, I forgot, this value is n, not m. It is m, not m, because it is with dy, right? So it is m, not m, right? So we're going to be having the integral of 2y multiplied by 1 over x, right? That's this part of the equation here. This is our m, right? Then we have dx. You will know that is your m by the one that that's with dx, right? Is your m, and the one that's with dy is your n, right? And then we have plus the integral. So now if you check on this side of the n, the one that has only y is this one. So you have negative y dy, right? So we cannot take 2 log x because there is no value of y there, and because there is a value of x, there is a variable of x there. Now, when we integrate 2y times 1 over x, 2y is going to be a constant, right? We're extending with respect to x. So we're going to have 2y multiplied by the integral of 1 over x dx minus 1 integral of y dy is equal to c, not 0, c. So here we have 2y ln x, then we have negative y squared over 2 is equal to c, and then we are going to multiply through by 2, so we are going to have 4y ln x minus y squared is equal to c, and this is going to be our final answer for this particular question. So it's very simple. In some cases the 2y might be represented as sorry, the ln x might be represented as log x, right? So it is still exactly the same thing, but basically this is the answer to this question, and you're going to solve case 2 the exact same way, right? The only difference is the formula, right? The formula, and then you're going to end up with a function of y instead of a function of x. But the same thing, after you get your integrating factor, you are going to be multiplying the entire equation by that integrating factor, and then you're going to be solving using the base form method. All right, so let's look at this question. So for this question now, let me change this to a pen. So for this question, we're going to be having y log y dx plus x minus log y dy is equal to 0, right? So now we have this expression here. So the first thing we're going to do is bring out our m, and our m is going to be y log y, and our n is going to be equal to x minus log y, and now we're going to get our dm dy, and then remember we have y multiplying log y, so we're going to be using product rule, and now when we take the derivative of y, we are going to have 1 then multiplied by log y, which is going to be log y, and then we take plus the derivative of log y, which is going to be 1 over y multiplied by y, which is going to give us 1. Then we take dn dx, and then we take the derivative of x, which is going to be 1, and then the derivative of log y, which is going to be 0, right? And the reason why it is 0 is because there is no function of x there. There's no variable of x in that part of the question. So now you can check dm dy, and you can see that it is not equal to dn dx, right? So we're going to go to case 2, and we're going to solve using case 2. So now dn dx is 1, then minus log y plus 1 over m, and the value of m is y log y, right? So we're going to be simplifying this. We're going to have 1 minus log y, then minus 1 over y log y. So you have this expression, and now we're going to simplify this. So we're going to be having 1 minus 1, right? And this is going to be equal to we're going to have minus log y over y log y. So here log y is going to cancel out log y, and our final expression is equals to minus 1 over y, and we can see that this is a function of y, and that is exactly what we want. So after we have gotten that, we are going to be finding our integrating factor of, so we're going to have e to the power of negative 1 over y dy, and this is going to be equal to e to the negative integral of 1 over y dy, and this is going to be equal to e to the negative ln of y, and this is going to be equal to 1 over y, right? After this we'll cancel this, will come here to be negative 1, so we have 1 over y as our integrating factor. So after getting 1 over y as our integrating factor, we're going to be multiplying the entire equation by 1 over y, and then we're going to apply our base form method, right? Our integrating factor is 1 over y, so we're going to multiply everything in the original equation. So we're going to have 1 over y multiplied by y log y dx plus 1 over y multiplied by x minus log y dy is equal to 0, right? So now we multiply, we're going to have log y dx, then we are going to have plus x over y minus log y over y dy is equal to 0. And now we're going to take the integral of m dx plus the integral of n dy is equal to c. So now basically, remember, we're going to be integrating the values of m with respect to x, but the value of n that we're going to integrate must have only variable y. So now we're going to be having the integral of log x dx, right? Because that's the only value of x of n that we have. Then plus the integral of negative log y over y. You check here, only this one has only the variables of y. This one has x, y. So the x already there disqualifies it. So we have the y equals to c. And now we are going to be integrating both sides. So if we integrate log x, we're going to get 1 over x. And then we have negative the integral of log y over y. So now we have log y over y. How best can we integrate this? So basically we are going to be using integration by substitution. So we're going to have let u equal to log y, then du dy is equal to 1 over y, and then we'll make dy solid of the relation. So that means dy is equal to y du, and when we're going to substitute it into the equation, so we have 1 over x minus the integral of u over y times y du is equal to c. So y we cancel out y, so we have 1 over x minus the integral of u du is equal to c. So we have 1 over x minus the integral of u, which is going to give us u squared over 2 is equal to c. Then we'll multiply everything by 2. We're going to have 2 over x minus u squared is equal to 2c, which is basically the same thing as c. So we have c here. So now this value of u, we are going to replace it, right? Because we know that u is equal to log y, right? When we were integrating by substitution, we substituted the value of log y to be u, and u was not in the original equation, so we have to substitute it back. So we have 2 over x minus log y, then we have our square is equal to c, and this is our final answer for this question.